So one of those really interesting uses of the Memento pattern is actually using it for interop. So you might be wondering why exactly you would use this particular pattern for interop as opposed to some of the other patterns. So let me explain. Let me show you a very simple schematic. So we're not going to do any code here. We're just going to explain, I'm going to explain how this whole thing works. Let's suppose you have some unmanaged C++ code. Let's suppose this code could be virtually anything. It could be native code. It could be something like CUDA. It can be something else, doesn't really matter. So you want to consume this code on the C# side, and there are different ways of doing it. There are actually tons of ways. For example, you can use COM, but the typical way is something called pinvoke, parallel invocation services, and the reason for this is to allow people to very easily call C or C++ functions out of C#. So the way this works is as follows. Let's suppose that you have some function f here. Now what happens on the C# side is you have this extern keyword. So you have extern static void f with the same arguments as you would here. So I'll just put a dot here for now, and then you would be able to, you don't put a body for this function, but you'll be able to actually invoke this function, and if it's decorated with the appropriate DLL import, for example, if you're on Windows, DLL import attribute, what you can do is you can actually call into this function and pass parameters. Now there is a bit of a problem in the C# C++ interop, and this problem is that you can only pass in things like pointers, for example. So if you have an array of data, so you have an array of 32-bit integers, then in C#, if you want to pass it into C++, for example, what you do is you use the fixed keyword. So you say something like, I'm going to have a fixed integer pointer called p initialized to whatever actual array you're working with, and then you would pass this argument p, and you could pass it in here into the arguments, which would kind of forward it into the arguments here, and then you can work with this memory. And this only works for very simple types. Now the problem is that sometimes you want to return an object. So for example, here you might want to construct a person, which is a C++ class. So it's class person with, you know, some public members like age, for example. And you want to actually pass this and return it from some function g. So you have a function g which returns a person, and you want to pass it here. Unfortunately, you cannot do it directly. You cannot simply make a class here, class person. You cannot simply make a class which would replicate this class and have binary compatibility one with the other. So there are different approaches to this, and one of them is you can try to get the structure layout just right. So you can try to build a struct here which replicates all of the fields, but then of course you might have something like a string or a W string here, and then you're really in trouble because we cannot really put a string in here and have some sort of equivalence between the two. That's simply not how it works. So what you can do as an alternative is you can use the Memento pattern. So whenever somebody calls G on this side, so whenever somebody has this, we still have this function G, it might be a person token. What you can do is you can actually store G on this side. So if you have some cache of these G's, let's say you have a vector or maybe a map from, let's say, person token to person, and it's called cache. What you do here is you make a new person, you stick that person into the cache. So you say something like cache at, and then calculate some sort of hash code maybe for the person, or some sort of essentially the memento. So here you make a new token, so cache at token equals whatever this thing is. So this goes in here, and then what you do is whenever you have this invocation, let me just extend the line here, you actually return the token. So you return the memento, and that memento can go in here, and that memento can be as simple as an integer. So now the C# part has some sort of integer which refers to the person, but you cannot really operate on it, meaning you don't have the fields directly, you don't have anything directly. But once again, the upside of this is that if you want to perform some operations on the person, let's suppose at some point you want to pass the person back into the C++ side of things, what you can do is you can take that token, and here I'm saying it's an integer. It can be virtually anything that is serializable and easy to send across the boundary, and you can actually pass that token in here and call some sort of API. So if we have some sort of other API, let's call it function Z, which actually takes a person token, then what you can do is you can have a platform invocation here for Z, which takes exactly this thing, whatever it is, and it actually invokes the appropriate DLL. So the Memento pattern is actually rather useful when you do interop, because it lets you operate on objects without actually having those objects as a kind of construct that you need to serialize across the different boundaries. So in this case, it's on the one hand very inconvenient because you don't have direct access to members of person. Like for example, if it has an age here, you cannot really access the age here, but what you can do is you can try and get the API to maybe return to you the age. So maybe you have more global functions, and unfortunately, yeah, these have to be global functions, all of them, but if they are, then they can return certain information about the person. That's the best that we can do, because unfortunately we are unable to serialize and send across the boundaries entire objects because they're binary incompatible.